Hello, my name is Gavin Padilla, and I'm going to be reviewing the Unit 1 test review problem number 1. So the problem is essentially asking us to answer like 4 various questions about this position versus time graph. And then question 1 is to describe the motion of the object. And so let's look back at the graph. And so we see a linear line, and we also see that it has a y-intercept of 0, and it ends at 6 seconds at 60 meters. So we see that there. And based off this information, what we know about the motion of the object is that the object is moving in the positive direction and at a constant velocity. It's moving at a constant in a positive direction because we see that the linear line is increasing, and if you take the slope of any point in this line, it will be a positive slope, which is why it's moving in the positive direction. And then it has a constant velocity. This is because the slope of a position versus time graph is velocity, and if you were to take the slope at any point in this line, it would always be the same value, which means that velocity is constant. And then the second question is determine average velocity of the object. So determining average velocity, that's basically asking us to find the average slope, since velocity is the slope of this position time graph. So in order to find the average rate of change, which is the velocity, we can use the equation of y2 minus y1 over x2 minus x1. That would give us the average rate of change, which is the same thing as slope. And so we need 2 points for this equation. So I picked 0, 10, and 6, 60. And so once we plug those numbers into the equation, we have 60 minus 10 over 6 minus 0, which is equivalent to 50 over 60. And then once that gets, once that you kind of simplify that, it's 25 over 3. And that approximate value is roughly 8.33 meters per second. And that means that the average velocity throughout this whole 6 seconds is about 8.33 meters per second. And so for question number 3, it's asking us to write a mathematical expression to describe the object's motion. And in order to write a mathematical expression for this, we need to know what type of line this is. So this is a linear line, and we can describe a linear line using the equation y equals mx plus b. So we're going to have to use information from this line and put that information into the y equals mx plus b format. And so here we have the y equals mx plus b, and let's look at the different information and what each number means. So the m is the rate, which we just found in the previous question. The b is the y-intercept, x is time, and y is position. So we only plug in m and b because we want the x and y to apply for the whole entire graph, so we can plug in any x or plug in any time, and then the output would be any position we want. So we're just plugging m and b. So m is the rate, and we found the rate to be 8.33 meters per second. That is the average, that is the rate of change of this line. And then the b is the y-intercept, and we see that the y-intercept is when the x-axis is 0, what value is the y-axis, and that value is 10. So we have plus 10 as the b value. And so the total equation equals y equals 25 over 3x plus 10. So with this line, you can basically just plug in any time, and then you can get the output of the position. So now it's asking us to apply the equation we just found. So use your equation to find the position at 20 seconds. So 20 seconds is basically time in seconds. So the thing that correlates to time is the x in this equation. So instead of just having the x as a variable, we now state that x equals 20 right there, and we plug it into the equation. Y equals 25 over 3, and I'm using 25 over 3 and not 8.33 because 8.33 is just an approximation and not the exact value, so we're just trying to be exact as possible. 25 over 3 times 20 plus 10. So 20 times 25 over 3 is 500 divided by 3, and plus 10. Overall, that is approximately 166.667 meters. So with that information, at x equals 20, which basically means at 20 seconds, the object has traveled approximately 166.667 meters. So that is their position at that time.